Hello my friends of Hadari Labs, welcome to the first part of the modeling of effluent discharge on the sea. Okay, so what we are going to model now, we are going to model this case study. The case study is on effluent, yeah, and this is a part of the sea, yeah, where we have a sea current, yep, that comes from this side and goes this side, yep, and then we have a effluent that gives 40 liters per second, and the sea current is about 0.05 meters per second, I guess. Yep, 0.05 meters per second. Okay, so this first part is just the geometry. So in order to create this geometry, we need Salome Platform. Oops. Salome Platform is, where is Salome Platform? I go here, see. Okay, I have here Salome Platform that you can download from the website, yeah, and then I just run Salome. And then okay, great. So this is Salome, and on Salome we have the geometry, new geometry, and then we have to insert the points by hand. Okay, so the first point will be, or whether you can insert it by code as well, like the second will be 0 0 minus 7, apply. The third point will be 0.47, apply. Then the fourth point will be 0, apply, and then will be 20 0 0, apply. Then will be 20 minus 1, apply. Then will be 40, apply, and then will be 0, apply. Okay, you will get a list of these points on the description. Okay, yep. Okay, and then I need some other points, that is will be 20, 10 minus 0.4, apply, and then 21, 10.4, 0. Okay, apply and close. Okay, so what do we have till now? Okay, so here we have many points. Do you see? Okay, so here we have many points. So we are going to create, first we create some edges, and from the edges we create some faces, and then we create a solid. So here I create build a wire, no, this one, curve, close wire, and it's preferable to select here with control, with shift, while keeping the shift key pressed. Okay, you have this wire, I say apply, and then I have as well this wire, apply, and then they have this wire, apply, and then I have this wire, apply. Okay, so I have already this, and then I want the top, apply, and then I want the bottom, apply. Okay, so I have 6 curves. Okay, so great. So I have, let's check if you have some curve. So I will close. So I have this curve, this curve, this curve, this curve, this curve, and this curve. So you have every curve in order to make this solid. And then what else? So we create a face. So we created from the curve. So we say we create a face here, a face here, a face here, a face here, a face on the back part, apply, and a face here, apply and close. So we have already 6 faces, and then I select the 6 faces. So actually, because this will have an entire volume, and then I create a shell from the 6 object. Okay, and then I have created a shell. You have to remember, this is a shell, this is like the envelope of your solid, and then with this you create a solid. Okay, apply and close. Okay, great. So here we have our solid. That's great. So right now we have a solid, and this is amazing. Okay, what else do we want to know? We want to have, well, we want something that we might want is the effluent, because the effluent is actually the latest 2 points were the points reserved for the effluent, and then I am going to create from these 2 points a solid. Okay, so I create a box here. No, it's not a box, it's a box. A solid from, no, it's not a solid. What? Sorry. It's a box. Yeah, it's a box. Yeah, and point 1 will be 0.9, and point 2 will be 0.10. Okay, and this is the effluent. Okay, great. So okay, so you have already 2 solids, and then I'm going to select these 2 solids. So this is one solid and this is the other solid, and then I'm going to fuse them. Why? Because my model is an entire solid, is not 2 solids. Okay, so I select this, select, oops, sorry, no, this is fuse, this is fuse, this is fuse, sorry. So I will create this with this, so these 2 objects, and it will create the one single object. Okay, so far you have done great. So if you have this, yeah, you will. So just for the sake of this tutorial, I will export this as a brep. Yeah, why I will export this as a brep? Because I want that you have an output of every step of the model construction. So for me it's important that, okay, you have this. Yeah, okay, so this is fuse 1, so this is fuse 1 as prep. Yep. Okay, great. So what else do we need? Okay, we'll have to define some groups. So say create group. Okay, and this is group from faces, and this group will be atmosphere. Apply. This phase will be effluent. Apply. This one will be inlet. Apply. This one will be outlet. apply. Okay, great. And the rest will be model wall. So actually this, and here this, and this, and this. Yep. Okay, once again, because I have lost track of what I have. First, the ones from the effluent. These. 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 Okay, so here I have 3. Okay, these are from the effluent. Then I have this one. Then I have this one. And then I need this one. Okay, I hope that your spatial construction skills are high, because it's actually this everything is 3D. Okay, and this is will be model wall. Apply and close. Okay, great. So here is the fuse, but the fuse is consists of the atmosphere, that is the top, the effluent, no, the inlet, the outlet, and the effluent. Great. And here we have the model wall, that is everything that is not the inlet, the outlet, and so. Okay, great. Okay, great. So now we are going to create a mesh. So in order to create a mesh, we have to save our project. Why do we have to save our project? So this will be case study. Yeah, because we need to, I need every step for your because I really need that. I mean, things can go wrong, maybe you have omitted something, so on, and so in order that you, if you don't want to lose all that you you have done, please save it. Okay, so then we go to mesh. On mesh we create a mesh, and then I am going to create a simple mesh. Yeah, and this mesh will be, this is the simple mesh. Okay, apply, close. So okay, and then I compute it. Okay, and this is my mesh. Yeah, this mesh is not optimized. Okay, so what does it mean? That this mesh is actually I mean, for the purpose of this modeling work, is not well optimized. Okay, I will tell you something. We have done a tutorial just on mesh refinement, yeah, with by using some codes in Python. Okay, so this is the code. Yeah, so I strongly recommend you that you follow this tutorial if you want to. I mean, in this part we are going to use the discretization, but if you want to tune in, if you want to run something very fancy for your model, please follow this tutorial. Okay, great. So okay, I will delete these meshes. Delete. I will delete this as well. Okay, so I will go to mesh. I will create mesh. The mesh will be from fuse 1. That's great. That will be netgen 1D 3D. Then I will edit, and then in here on local sizes, you will find okay, no, sorry, you will find you will find this MSZ file that is a file that defines a refinement area. So okay, so actually you will Control C here on the description of this. You will have a text. Okay, this is the file that you will find. So mesh file txt. Okay, great. Okay, apply and close. And now if I compute, right click, compute. Okay, then I have a very fancy mesh that I have one discretization, second discretization, and third and the coarse, or like the normal mesh. Okay, so great. So right now I have the mesh, and now what I have to do is to associate the patches to this mesh. So I will create mesh, create group, and on this group face, group on geometry, and they say okay, atmosphere will be atmosphere. Okay, apply. Then effluent goes as effluent. Maybe you can change, apply. Then the inlet will be inlet. Then the outlet then the outlet will be outlet. And then mother wall will be mother wall. Okay, apply and close. And now you have your mesh, but you have the atmosphere, that is the top part. Then you have the effluent, that is this part. Wait. Yep. Okay, I have, excuse me, this is wrong. Why this is wrong? Because actually I have to do it again. Okay, and that's great, because like everybody makes mistakes here. Okay, on the mesh, create mesh. Yeah, I will use the fuse one. Yeah, why not? And then I go to tetrahedral, then I will go this one, and then I will create. But this, I mean, look here on this, the minimum is 0.2, I guess, the refinement. So, and this is 0.4. So actually this will rule the other one. So actually it doesn't matter if you have inserted 0.2 in the local mesh refinement, if in here in the minimum size is actually if it is bigger, actually it wouldn't matter if you have some mesh refinement with lower values. Okay, so this has to be 0.2. Apply and close, and then if we compute it, okay, close here. Okay, have you seen this? So actually here we have 0.2 value here, while in the other part we have only 0.4. So here we have better. Okay, here you can see the three discretization: normal discretization, the first stage refinement, and the second stage refinement. Okay, great. So sorry for this, it happens every time. So actually, like if you want to do your first OpenFOAM on the first attempt, like whether you are lucky, you are divine, you are extra intelligent, or please send me an email because like you are super talented to this. In my case, the trial and error procedure is always the rule. Okay, so I create group, and the group will be on phases, group on geometry. This one will be atmosphere, and this will be effluent. This will be inlet, and this will be outlet, and this will be model wall. Apply and close. Okay, great. So right now this is different because here we have the atmosphere, this will be the effluent, and the effluent consists actually of 6 phases. Okay, then we have the inlet, and then we have the outlet, and then the model wall. Okay, so okay, and that's it. This is the atmosphere. Okay, so we are going to export this mesh 1 as like export UMV as, okay, I will delete something here, sorry. So this one won't be here, and this one will be here. Okay, and the refinement as well is not here. Okay, great. So this will be mesh 1 UMV. So what we have done, this is the case study, but this is the other version of the case study. I will create a new one. This is the prep, this is the geometry of the model, and this is the first mesh. This is the mesh that we are going to simulate on OpenFOAM. Yeah, and as well here is the refinement. Okay, great. So what else? Okay, I save this as a case study B because the other is A. Okay, that's it for this video, and hope to see you in the coming video where we are going to pick some tutorial from the phone tutorials, and then we are going to shape this tutorial in what is from this tutorial we are going to shape in the requirements of our case study. Okay, so thank you for following us. Please, if you like this, subscribe to this YouTube channel, and hope to see you in coming tutorials and in the second part of this tutorial as well. Bye bye.